let's talk about something truly amazing: light. It's something we often take for granted, but it's absolutely fascinating. From the moment we wake up to when we switch off the bedside lamp, light plays a starring role in our lives. It wakes us up, helps us see, and even affects our mood. It allows us to see the world around us in all its vibrant colors and textures. Imagine a world without light. Everything would be in darkness, and we wouldn't be able to appreciate the beauty around us. But have you ever stopped to think about what light actually is? It's not just something that helps us see, it's a form of energy. How does it travel from the sun, millions of miles away, to illuminate our planet? Light travels in the form of waves, moving at an incredible speed of about 186,000 miles per second. Get ready for some illuminating facts. Light is not just a single entity, it's a spectrum of different wavelengths. Light is more than just what our eyes perceive, it's a form of energy that travels in waves. These waves can be long or short, and they carry energy across space. These waves are part of a larger spectrum called the electromagnetic spectrum, which includes radio waves, microwaves, and X-rays. Each type of wave has its own unique properties and uses. Each type of wave has a different wavelength, and our eyes are only sensitive to a small portion of this spectrum, which we perceive as visible light. This visible light can be split into a rainbow of colors using a prism. Isn't it incredible that we only see a tiny fraction of the light that surrounds us? The universe is filled with light of all kinds, much of which is invisible to the naked eye. So next time you see a beam of sunlight or a starry night sky, remember, there's so much more to light than meets the eye. Both. Now here's where things get really interesting. Light can act like both a wave and a particle. It's a wild concept, I know. When light travels, it behaves like a wave, spreading out like ripples in a pond. This wave-like behavior explains how light bends around corners and creates interference patterns. But hold on, there's more. Light can also act like a stream of tiny particles called photons. Each photon carries a specific amount of energy. This particle-like behavior explains how light interacts with matter. For example, when a photon of light hits your eye, it's absorbed by a special cell which sends a signal to your brain, and voila, you see. Light travels incredibly fast, approximately 299,792,458 meters per second in a vacuum. This speed is so immense that it's almost impossible to truly comprehend. Imagine a beam of light leaving the sun and reaching Earth in just about 8 minutes. That's 93 million miles covered in less time than it takes to make a cup of coffee. That's fast enough to circle the Earth over 7 times in just 1 second. To put it in perspective, if you could travel at the speed of light, you could go from New York to Los Angeles and back again almost 40 times in the blink of an eye. This speed is the ultimate speed limit in the universe, meaning nothing can travel faster than light. Even the fastest spacecraft we've built would take thousands of years to reach the nearest star, but light does it in just over 4 years. Scientists call this the speed of light, and it plays a crucial role in understanding the vast distances in space. It's a fundamental constant in physics, shaping our understanding of the universe's structure and behavior. Think about it. When we look at distant stars and galaxies, we're actually seeing them as they were in the past. The light we see today started its journey millions, even billions of years ago. The light from celestial objects has taken millions, even billions of years to reach us. This means we're looking at a snapshot of the universe's history, a cosmic time machine showing us the past. It's like looking back in time. Every star, every galaxy we observe is a glimpse into a different era of the universe. The speed of light is essential for astronomers to study the history and evolution of the universe. By measuring how long light has traveled, scientists can determine the age of stars, the distance of galaxies, and even the rate at which the universe is expanding. It's a key to unlocking the mysteries of the cosmos. Light is essential for life on Earth as we know it. It is the driving force behind many natural processes that sustain life. Plants, the primary producers of energy in most ecosystems, rely on light for photosynthesis. This process is fundamental to the survival of almost all living organisms on our planet. During photosynthesis, plants use sunlight, water, and carbon dioxide to create their food, releasing oxygen as a byproduct. This oxygen is crucial for the respiration of most living creatures, including humans. Without light, plants wouldn't be able to produce the energy they need to survive, and neither could we. The absence of light would lead to a collapse of the food chain, affecting every living being. But it's not just about food. Light influences many aspects of our daily lives and well-being. Light also plays a vital role in our sleep-wake cycles, mood regulation, and overall well-being. Exposure to natural light helps regulate our circadian rhythms, ensuring we get restful sleep and feel energized during the day. Exposure to sunlight helps our bodies produce vitamin D, which is essential for strong bones and a healthy immune system. Vitamin D deficiency can lead to various health issues, including weakened bones and a compromised immune response. So, next time you're basking in the sun, remember that you're soaking up more than just warmth. You're benefiting from the life-giving energy of light. Embrace the sunlight and let it nourish your body and soul. Section 5. Color me. Intrigued. Unpacking the spectrum. Remember the electromagnetic spectrum we talked about earlier? Well, the visible light we see is just a tiny sliver of that spectrum. When white light passes through a prism, it separates into its different wavelengths, creating a beautiful rainbow of colors. This rainbow is known as the visible light spectrum, and it ranges from red with the longest wavelength to violet with the shortest. Each color within the spectrum has its own unique wavelength and energy level. Red light, for example, has a longer wavelength and carries less energy than blue light. This difference in energy is why we perceive colors differently, and why some colors appear brighter or more intense than others. Section 6. Lightbenders and illusions. Fun with optics. Have you ever wondered how glasses help us see more clearly, or how a magnifying glass can focus sunlight to create enough heat to start a fire? It's all thanks to the fascinating field of optics, which studies the behavior of light and how it interacts with different materials. Lenses, like those found in glasses and cameras, are designed to bend or refract light in specific ways. By controlling the way light bends, we can manipulate it to magnify objects, correct vision problems, and even create stunning optical illusions. Think about how a mirage in the desert tricks your eyes into seeing a pool of water where none exists. That's the power of light and optics at play. Section 7. Beyond the bulb. Light in technology. Light plays a crucial role in countless technologies we use every day. From the screens of our smartphones and computers to the fiber optic cables that carry vast amounts of data across continents, light is the unsung hero of the digital age. Lasers, which produce highly focused beams of light, have revolutionized fields like medicine, telecommunications, and manufacturing. In medicine, lasers are used for everything from delicate eye surgery to removing tattoos. In telecommunications, they transmit information through fiber optic cables at lightning-fast speeds. And in manufacturing, lasers are used for cutting, engraving, and welding materials with incredible precision. The applications of light in technology are vast and constantly evolving. Section 8. Light's future shining brightly. The future of light-based technologies is incredibly exciting. Scientists are constantly pushing the boundaries of what's possible with light. One area of active research is quantum optics, which explores the bizarre world of light at the quantum level. Quantum computers, which harness the principles of quantum mechanics, have the potential to revolutionize fields like medicine, materials, science, and artificial intelligence. Another promising area is Li-Fi, a wireless technology that uses light waves to transmit data. Li-Fi has the potential to be much faster and more secure than traditional Wi-Fi, and it could even be used to provide internet access in remote areas without existing infrastructure. The future of light is full of possibilities. Section 9. Keep exploring the luminous world. So there you have it, an illuminating journey into the world of light. From its fundamental nature as both a wave and a particle to its essential role in life and its countless applications in technology, light is a truly fascinating and essential part of our universe.